Good evening, ladies and gentlemen. I hope you guys are doing fine and you guys are studying hard for your coming assessments, quizzes, and so many stuffs that are coming along your way. So in today's class, we are just going to continue from where we ended, and this class is simply the physics class. So what we are just simply going to look at is Newton laws of motion. Specifically, this is our part 2 of our lecture class. That simply means that in this part 2, we are much focused on knowing how to apply the concepts that we had to learn or discuss last time. So I do believe most of us have gone through our part 1 of this class, so I hope we are not going to be just passengers or get confused. Instead, we'll all be freely participating. So before I move on, I would love to confirm if you guys are able to get me or not. So can just someone kindly confirm with me? All right, thank you very much for that confirmation. So like I've already stated, we'll look at part 2 of Newton laws of motion. Mostly we'll look at how we can apply the concepts which we learned last time in lecture 1. So please make sure that you are able to check out lecture 1 and you are able to follow up and ask questions in this lecture. Okay, so let's quickly look at our first question. So the first question is saying a 30 kg car that can move freely is subjected to a resultant force of 45 Newton in the x direction. Find the acceleration of the car. So this is a very easy question that you can apply in terms of Newton laws of motion. So we can look at our boy there. So this boy has pushed this car, and the force which this boy has pushed, you can see a blue line there, which is just simply showing the force, and it can also show the direction. So we have been told that the force that has been applied on this object is just simply 45 newtons. So we are going to collect our data, which is information. We are going to say the force is simply equal to 45 newtons. So that's the force which has been applied. And then the other guy which we need to understand is the mass of this toy. So the mass of this toy is simply 30 kg. So the mass is simply 30 kg. So what are they asking us to find? So what we have been asked is to find the acceleration, of which we know that the acceleration we have not been given, and this is going to have a question mark since we don't know the acceleration which this object was moving. In terms of the diagram, I can simply draw a car like that. So this is our car, and this car is the one which has been pushed by a boy. So that's the car. So first thing, as a physics student, you need to make sure that you are able to identify the forces that are acting on this particular object. So there are so many forces that are acting on this particular object. So you have the normal force, which is the Fn. You also have the force due to gravity, which is just the weight. and now you have the resultant force, which is simply equal to the force R which has been subjected, and then there is a friction force which is acting on the tires, and this can just be F small letter r. So this can be small letter r or F. Okay, so this is the friction force. There you have the resultant force, there you have the normal force. So if you look at this car is moving in the X direction. That simply means that we can treat the Y component, which is the Y component, the resultant in the Y component, which is equal to the Fy. Okay, you can treat this guy to be equal to what? To be equal to 0, since there is no acceleration in the Y component. But for the X component, is the one which you are much interested in. So what you are supposed to do now is just to apply the formula. I have given this part because I want you to really know the concepts behind everything, and not just automatically go into something and solve. So one thing that you need to understand is force is equal to mass times acceleration. So you need to make sure that everything is in the SI unit. Everything is in the SI unit. So what we are going to have is just 45 Newton, and then the mass is simply 30 kg, and then times acceleration. So you can easily work out over 30 over 30. So acceleration is equal to, can someone punch for me 45 divided by 30? What's your answer? (45 divided by 30). Anyone who has already solved? What is 45 divided by 30?
1.5.
1.5.
1.5, sir.
All right, thank you. So 1.5 meters per second square. So this was the
1.5.
All right, so 1.5 is the final answer. So sometimes you might be asked, let's say this guy here is in the negative x direction, So if it is negative x direction, then this one will be what? Will be negative, if that statement was in the negative direction. So that's how easily you can work out the first question. So let's quickly look at the next question. And on the same question here, if you want, you can just go direct to the white part which I have solved here without going the yellow part. The yellow part I went there because I want you to not just know how to solve, but to also know how to apply the concepts. Okay, with this being said, let me move on and look at the next question. So the question is saying a horizontal force of 170 Newton, is needed to pull a 60 kg box across the horizontal floor at constant speed. So that's what we have been given. And then what is the coefficient of friction between the box and the floor? So one thing that we have been given here, which we need to have interest in, is the force acting on it, which is the horizontal force. And also we have been given the mass of this box, and then the other thing that we have been asked to find is the coefficient of friction. So let me quickly work on this question, and let's make sure that we follow how I'll be doing it. So this is the box which is there. So we are going to treat this green guy here with gray inside as the box. So this is the box, and then this is the floor. So the brown part is the floor, the brown part is the floor, and the green part is just the box. So let's quickly analyze the forces which are on this particular box. So this box is simply having it is simply having this force which is pulling it upward. So the force which is pulling it upward is known as the normal force. So the normal force will be regarded as the Fn. Take note of my explanations. The first thing that you need to do is to view this question in terms of the diagram. So the first thing that you need to understand is when you draw, you need to make sure that you analyze the forces that are acting on this particular object. The first force is the normal force. The first force is the normal force, which is Fn. The other force which you can talk about is the one which is moving downward. So the one which is moving downward, it is known as the Fw, which is the force due to the weight, the force due to the weights. And then another force that you need to consider is the one which is going this side. So this is the force which was applied. Remember, there is the horizontal force. There is this horizontal force. So this horizontal force is the one which we can analyze, which is just F. So what is the size of this force? The size of this force is just 170 Newton. So when we have this information, the next thing that we need to understand is another third force which is acting on this particular object. This force is the force due to friction. The force which we need to look at is the force due to friction, which is F and then small letter f. And that force is the one which is acting in between the box and also the surface of the floor. So these are the forces that you need to take note of. Remember, the black spot here is just showing the center of gravity. So from this information that we have, one thing that you need to know is, for you need to understand also the free body diagram. And this free body diagram, it's this same thing which I have clearly explained. So this is the more like a free body diagram. If you want, you can just sketch it in that way. You say that one as your Fn, and then you have this one here which is the F, which is 170 Newton, and then you have a downward force which is Fw, and then you have the other force which is the force due to friction. So those are the forces that you need to understand. Now, one thing that we need to understand is, because this box is in this form, so we also have the Cartesian plane. So you have the y component and also the x component. So let's quickly look at the solution. Remember, we have two components of a force according to our lecture 1. We have to make sure that we find the summation of forces in the y-axis and also the summation of forces in the x-axis. Why? Because we know that force is a vector quantity. So the summation of forces in the y-axis can be m acceleration y and then also m acceleration x for the x component. So let's quickly look at the y component. Let's quickly look at the y component, since forces are just what? Are just a vector quantity. So in the y component, you're going to say summation of forces in the y component is simply equal to m multiplied by acceleration y, of which you know that m is what? Is mass, and then ay is simply the acceleration in the y component. So this is the acceleration in the y component. So one thing that you need to understand, this object is on the floor and the only resultant force you're having is this one. So this simply means that ay is simply equal to what? 0 meters per second squared. Why have we said ay is 0 meters per second squared? It's because there is no movement in the what? In the y component. Therefore, the summation of forces in the y component is simply equal to the mass, which is 60 kg. So you say 60 times 0, and the summation of forces in the y component is simply equal to 0 Newton. So this is the summation of forces in the y component. Now, one thing that you need to understand once again is we have the forces in the x component. So let's quickly look at the summation of forces in the x component. So I'll quickly put the x component. So this is how you need to make sure that your work is presented, because presentation of the work also matters both to the marker and you who is working on the question. So let's quickly look at the x component. So the x component will say summation of forces in the x component. The summation of forces in the x component is equal to, you're going to do what? You're just going to find the same guy which we have. So the same guy which we have is what? Is 170 Newton, isn't it? So we have 170 Newton, which is the guy that we have as the force, this force here. Now, one other thing that we need to understand is that this 170 Newton here, 170 Newton, it is having a friction force which is acting in the opposite direction. So you are going to subtract the friction force from what is acting in the opposite direction. So you are going to say F of what? Friction, like that. So this is the summation of forces in the what? In the x component. Okay, so with this in mind, which we know that the summation of forces in the x component is 170 Newton. 170 Newton is coming from this force and then minus the friction force which is acting on this. So what we are now going to do is we are going to treat the acceleration in the x component of this guy to be equal to what? To be equal to 0. So what we are going to, the reason why we are making we are trying to get rid of the summation of forces in the x component, we are just treating these forces to be equal to 0. So we are going to say 0 there is equal to 170 Newton minus the friction force. So from this information which we have been given, we can say therefore the friction force is simply equal to 170 Newton. Okay, the friction force is equal to 170 Newton. One of the part which you guys might be wanting to understand, it's why is this guy having a 0? Why is the summation of forces having what? 0 here. So this guy is coming from the fact that this object is moving at a what? At a constant speed. So when an object is moving at a constant speed, you need to understand that the acceleration is what? 0. So the acceleration is 0 when the object is moving at a constant speed. In short, what we know is that summation of forces of f of x should be equal to max. But because the speed is constant, ax will be equal to 0. So summation of f of x is simply equal to 60 times what? Times 0, which is simply giving you what? Which is simply giving you a 0 Newton. That's why this guy here, f of x, has come out as a 0. Now, after you understand that, you now need to look for the value of the what? Of the normal force. So first we found the value of the y component. There is no acceleration, so it's 0. Even the x component is 0 because it is at the constant speed. Now the next thing is for you to try to find the normal force. So let's quickly look at the value of the normal force. So how can you easily find the normal force? So remember from the previous class, we said in most cases, but not all cases, but in most cases where the body is at rest and the forces acting on them are not at an angle, in most cases you need to understand that Fn, which is the normal force, is equal to what? Fw. So the normal force is equal to the weight of an object when that body is at rest. So we know that Fw is simply equal to what? Mg, of which you know m is just the mass of the object and g is the acceleration due to gravity. So taking the acceleration due to gravity to be equal to 9.81, so you can now say 60 kg times 9.81. So when you work out this calculation, you're simply going to have 60 times 9.8. Can someone work for me that? 60 times 9.81. What are you having? Someone?
588.
Sorry?
588.
Okay, so you are having 588.6 Newton. Remember, there is a 1 there because we have treated the acceleration to be equal to 9.81. Therefore, from this information that we have gotten, since Fn is equal to Fw, so you need to understand now that the normal force is also equal to 588.6 Newton. So you have done this work so easily. The next thing that you need now to look at is to find the coefficients of friction, because now we are looking for the what? For the coefficients of friction. That's what we have been asked to find. So the coefficients of friction is represented in most books as UK, okay, U subscript K. So this is the formula that you need to make sure that you master when it comes to the coefficient of friction. So the formula of coefficient of friction which will be applicable, which is mu, and then K is simply equal to, the formula is the force of friction over the what? The normal force. The force of friction over the normal force. So this is the formula that you need to understand when it comes to finding the coefficients of friction. So from there you can simply say coefficients of friction, you're just going to get what we found as the friction force, which was what? What was the friction force? What was the friction force? Which is 170, and then the 170, and then the guy which is 588.6 Newton. Then this, when you work out on your calculator, please make sure that you plug it in on your calculator and you are going to finish it up. So that's how you can easily find the working or when it comes to working out these questions. Okay, let's move on and look at the next question. So the next question is the coefficients of static friction between a box and the flat bed of a truck is 0.5. What is the maximum acceleration? What is the maximum acceleration the truck can have along level ground if the box is not to slide? So that's one of an easy question that you can easily enjoy when you are working out. That's a very easy question that one should make sure that you are able to solve. So one thing that you need to understand that the box is experiencing only the x-directed force. If you look at the truck is moving there. So this truck is moving this side. So as it is moving, one thing that you need to understand due to its movement is that the boxes inside, or the boxes in this truck, are only experiencing what? One type of acceleration, which is the acceleration in the what? In the x direction. So with that in mind, you also need to understand that there is also the friction force which is acting on this on every box which is there. So if the x force is going in this direction, okay, this is the Fx force. There is also a friction force which is acting in that direction, which is the F. So the box is having two forces when you talk of in the x direction. Now, when you look at the movement, when this box is about to slide, okay, when this box is about to slide, you need to understand one thing. One thing that you need to understand is that you have the coefficient of friction, which should be equal to what? The coefficient of friction, which is supposed to be equal to the friction force over the what? The normal force. The friction force over the normal force. And then when you talk of the normal force, which is Fn, so Fn, which is Fn, is simply equal to what? Fw, right? Fn is simply equal to what? Fw. Now, Fw is equal to Fn. This simply means that we can easily work out this, whereby we can say Fn is simply equal to Fw, which is simply what? Mg. We know that Fw is equal to what? Mg. So with that in mind, you can also talk about another relationship which we can build from the information that we have. So another relationship which we can build is from F and the x direction force. The x direction force. So what we are going to say is summation of forces in the x direction is equal to the F minus the force of what? Friction. So with this in mind, we can simply say the force of friction is simply equal to what? The force of friction is simply equal to what? F of what? X. Now, after you do that, you can simply say F of friction is simply equal to MAX. MAX. So AX is just the acceleration which is causing this box, every box in this guy to have what? To have that motion, which is AX. So this is the information that you have. Your job now is to replace whatever you have, you replace it with the what? In the formula. Remember that what we also have, another thing that we also have is the coefficient of friction, which is just 0.5. So after you have this information, what you now need is you to now just replace your work. You replace these guys in that particular formula. So let me quickly replace that. So coefficient of friction is 0.5, like we have seen from the question there, which should be equal to the friction force is simply MAX. So MAX, okay, and then the normal force, which is Fn, is simply equal to what? Mg, right? Now what we have been taught is to find the maximum acceleration, okay, is to find the maximum acceleration. In short, we have been asked to find the acceleration in the in the x component. So from here, you know that we are just dealing with one box, okay? We are just dealing with one box. This simply means that the mass is just the same. So since the mass is the same, if we treat the mass to be the same, that simply means that this guy and that guy can easily cancel. So what we have now is 0.5 is equal to ax over g, okay? Then the data which we also have is for g. The information which we also have is for what? Is for g. So we can easily say 0.5 is equal to ax over what? Over 9.81. Okay, so here this can be treated to be a fraction. Also this can be over 1. So when you have that information, you can easily work out by cross multiplying. So when you cross multiply, you're going to have ax is simply equal to 0.5 times 9.81. So ax is simply equal to, can someone multiply for me those guys there? What are you getting when you multiply? Someone to easily work on that? Are people around? What is 0.5 times 9.8?
.905.
Come again?
4.905, sir.
4.905.
Okay, so we have 4.905 meters per second.
4.905.
Alright, I've gotten you. So that you can round it off. So this will simply be equal to ax is equal to 4.91 meters per second squared. So this is how easily you can work it out. Okay, I don't know if there are any questions, ladies and gentlemen. I don't know if you guys have any questions, so that we can move on to the next question. Okay, so let me quickly work on the last question, though it was not supposed to be the last question, but due to time, I have a class just after this class, so I'll just do this, the next question, and then we will continue next time in physics. We'll finish up other questions which I have for you guys. So we have the last question, which is a 7.8 kg bucket is to be given an upward acceleration of 0.6 meters per second squared by a rope pulling upward on it. What must be the tension in the rope? So we discussed different types of forces. We talked about the tension. We talked about the force due to gravity. We talked about the resultant force. We talked about the normal force, and so many forces that we discussed in part 1. So let me quickly analyze this question. Have been given a bucket, and this bucket is simply 7 kg. Okay, so this bucket is 7 kg according to the information I've been given, and then this same bucket is having an upward pull in the rope, and that pull which is there, and this pull is having an acceleration, and this acceleration is just 0.6 meters per second. Okay, so that's the information that I have been given from there. So what am I going to do with this information? What am I going to do with this information? So my job with this information, I need to analyze the same bucket and the forces that are acting on it. So it's very important to take note of all the forces that are acting on an object. So there is the bucket of interest, and this bucket has been tied to the rope, so that rope can be replaced by a force, and that force is the tension force. So the rope is causing the force, and the force which is in the rope is just the tension force which you need to expect. Then one other thing that you need to take note of is the force which is acting downward, and that force is simply the force due to gravity, and that force is the weight. So with this in mind, we can easily work on the tension force. We can easily work on the tension force by just simply looking for the summation of forces in the y component. We can just easily look for the summation of forces in the y component. So summation of forces in the y component, one thing that you need to understand is that Fy, which is the force in the y component, is equal to what? MAy. So this acceleration here will be treated to be what? Ay, because it's the one which is causing that. What other forces have we observed? We have also observed the weight which is trying to oppose, and this weight is what? Is mg. The other force, which is the force of interest, is the tension force, which is simply equal to we don't know. So with this in mind, anyone can easily work on that. So you can look at summation of forces in the y component. So remember, there is a force which is going this side, which is the which is the tension force, and there is also the W force which is opposing that force. Should be equal to, you're going to get the tension force which we are looking for minus the force which is opposing it. So the force which is opposing it is the weight, which is Fw. Okay, so why are we working out this question in this particular way? So the reason why we are working out this question in this particular way is that we just want to know how much was the what? How much was the tension in that force? Why? Because there are two forces. There are two forces that are balancing up this. There is the resultant force. This can be treated as the resultant force. So this resultant force, for it to be there, it's because the tension force somehow was greater than the normal force, or sorry, the weight, and that amount, that difference between the weight and the tension gave out that acceleration. Let me repeat that explanation. I'm saying there are more like two forces which are acting here. There is the tension force and the normal force. Now, one thing that you need to understand is that the difference between the weight and the tension force is what produced that force there, or that produced that acceleration. So with that in mind, we can easily replace everything. So here you're going to say m times acceleration in the y-axis should be equal to the tension force minus the weight, which is just mg. Then there you know that you can easily get the mass, which is 7 times the acceleration, which is 0.6, should be equal to the tension, which is the force in the rope, minus mg, which is 7 times what? 9.81. So when you write down that, you can easily make your calculations. You can say 7 times 0.6, so it is 4.2, and then you have ft. You say 7 times 9.81, it will give you 80.67. So after you have that information, what you are now going to do is you take that to the other side. So Ft, which is the force of tension, is equal to 4.2 plus 68.67. So the force of tension is just what? That guy plus 4.2. So it's going to give you 72.87 Newton. 72.87 Newton. So if we want, we can easily round it off. We can easily round off that figure. So if you want, you can round it off to 1 decimal place. If you want, you can round it off to 2 decimal places. So I'll round it off, or a whole number. So I'll just round it off to the nearest whole number. So Ft is equal to 73 watt Newton, which is the final answer. So in the next class, we'll look at more questions like this question. We'll also look at that other question and another question which is there. So we'll look at the other questions in the next class. Either I'll record it, or we'll have a class. So in the meantime, ladies and gentlemen, if you have questions, feel free to ask. If at all you will have questions later on, you can just WhatsApp me. So in the meantime, you are free to ask questions.